Welcome, part 26 or something. Yeah, we are slowly wrapping up the build or like the upgrade cycle today. So basically last time we did some other stuff. Basically we tried to fix some boards, which went semi well, I guess. I actually gave up on the step driver fix for now. Yeah, I don't know. I tried to like desolder and solder it back for like another 2 times, and like I always got this INFT register error. Yeah, I don't know. Like maybe it's me. I'm incapable of doing that, or something else on the board is broken. But yeah, for now it's fine. I'll just leave it at that. Yeah, but we fixed the RGB toolhead here, so that's some success. So we have the RGB lights back on this toolhead. Not quite the fix I wanted to do. So basically we replaced the component I thought it was broken, but it's still the same issue. In the end, we just bypassed the entire component. Like we removed it and just ran a jumper wire, and that fixed it. So seemingly this component was not as important. Yeah, so today I just want to wrap this up. There's one thing that's very important, one thing that's like improvement, and the third is just playing around, I guess. The first thing that's very important is we need to replace the fan. So at the moment, or like in the beginning, the fan was broken. Like it was touching the Nomi in the front, hydronic. And yeah, so the original fan was just broken. I then basically just ordered like a random 50-15 fan that was like super cheap from a local shop where I had to order some other parts as well. And it works. Like the fan is spinning, we have like airflow, but it's abysmally bad at cooling. So basically like all the overhangs are just like horrible. It's basically similar to not having any cooling fan at the moment. So I ordered this one at 3DO, which is the Honey Badger high static pressure fan with 9,200 RPM. So it's basically like overkill because we don't run it in an enclosure, but this should give extremely good cooling. And a bit of a specialty is like this is a 4-pin fan. So we not only have the 24 volt and ground connections, we also have a signal. So basically Clipper can sense how fast the fan is running, which is interesting, I guess. Like I don't think it's super important feature for the hard cooling fan. The nice thing is like you can detect if the fan fails. So for example, like if you have this for the hot end fan, might be more interesting. I mean also the cooling fan, like if it fails, the print will not end well most likely. But for the hot end fan, basically, let's say the fan fails, you can detect that and then you can stop the print. Same for this one technically. And then the third wire is just PWM. So this is not controlled by reducing the voltage. This is reduced by PWM, so similar to like a PC fan. So yeah, we will install that. There is a little bit of like extra work we need to do. So basically on the toolhead board on the front, we need to crimp a new wire. We need to extend one cable because the Nomi at the moment plugs into the 4-pin fan header, so we need to move that around. So yeah, a bit of work, but like not too bad. And hopefully with that we will have excellent cooling performance. The second thing I want to do is I have this tiny, I'm not sure why my camera doesn't really focus today, this tiny step-down converter. At the moment I use like one of those like regular buck converters for the controller cooling fan in the back, which is a 12-volt fan, and we need to replace the buck converter. Like I'm super bothered by having this like massive buck converter there. This part is small and nice, so we can basically just put some heat shrink around it and just like kind of like have an inline conversion. This one is quite a cool part actually. So I had small ones like this before, but they always failed quite quickly. So there's like one kind where on the back you can adjust the voltage, like the output voltage. But they, yeah, for some reason they blow out after like a couple hours of use. This one seems pretty good. I used it for something else as well. And this one has a variable input voltage, so it can take anything from 12 to 36 volts, I think, and just outputs 12 volts fixed. So it's really cool. So you can just basically, like, the input doesn't matter, you just get 12 volts out. I think so yeah, this one will be for the controller fan, and then I ordered this one a while ago. Like I printed the parts, but I ordered the hardware kit for that, which came from the UK, which took like quite a while to run. This is a belt tension meter, which was designed by PF Makes. So basically it's just like a spring and some screws and stuff in here. The black parts are not part of the kit, that's also what I printed, I just put it in here. But basically what this will allow us to do is like to measure the belt tension on the printer. So you just put the belt basically in between here, there's a spring, and then you will have a gauge reading here on the scale, how high the belt tension is. And then we just need to look up the proper belt tension for the switch wire, and then we can like tension our belt nicely, which I think is pretty cool. I actually printed twice. Hi there, Adam. So up to the audience to decide later which one we use. So yeah, I guess that's kind of like the introductory stuff. So step one, let's just fix the part cooling fan. Because this is like, I think the main, like the print performance of the printer is still not good. For some, like it just doesn't look nice. I don't have an example print right now, but it's not usable. And I'm really wondering why. I mean, the extruder could be an issue, but yeah. I mean, the things we changed are the extruder, and we changed the cooling fan basically. And I don't think it's extruder, to be honest. Maybe partly, but not fully. Like the overhangs I just see are really bad. So I just want to make sure that there's a proper part cooling fan in there before we start messing around with the extruder. But yeah, like for today, I also like want to like make sure everything prints nice. A bit back. Here we go. So basically at the moment the fan on the top is our part cooling fan. So this one we need to replace. And this one here is the Nomi. The problem is basically these 4 pins is what we need for the fan. So it kind of goes here later. And that means we need to move the Nomi. And the only, we could move it up to the fan header, but I'm not quite sure if that's super smart, to be honest. But there's like another 4-pin header here, which gives us 5 volts and ground. So this is like a CAN bus header technically. So I would just like map the Nomi onto this one. The problem is we need to extend the cable for that, because the cable is just a little tiny bit too short to make that little journey up there. We need to extend this cable. We remove this fan, and then we need to like mod the fan to fit in here again. Like as usual, we need to remove the ears. And yeah, then we also need to crimp a new connector. So that's kind of like the battle plan. Let's just start by taking everything apart. And then I guess we can start, maybe let's start with the fan itself, and then we can extend the Nomi cable. Yeah, and it's this like no-name Chinese weird fan. That is not really good. I mean, it's silent, right? I mean, I think it's a good fan in the sense that it's very silent. It just doesn't move any air. Depending on the use case, it might be excellent. Let's swap it. This one. It's always the interesting part, right? Like visually they're exactly the same. Just the motor that's different. Yeah. Let's see. Some feel like the focus is a little bit off today. I'm sure if it's Hi there, Jonas. Thank you, Tinga. So, let's see if we get this off. Right here. A bit easier to do it on the edge of the desk. Yeah, let's just use the file in a second to clean this up. I feel this fan housing is a bit harder than the other ones. There you go. Nice and round. Let's see if it fits. Also quickly clean out all the dirt. So, I think we also need to remove this little nose here. There we go. Try to wiggle the cables back in the cable channel. I hope they're not popping out right away again. I wanted to say thank you for the great Octave update. You're welcome, Jonas. You are welcome. I already started working on the next. But I really have to clean up a couple of things. Like the last year, I always like kept like trading these things, but I still have a couple of like cleanup jobs left to do. So I think the next one will be a bit smaller. The only thing that will be new for the next one, depending on your operating system, you will love it or not. But for iOS, I'm adding widgets. That's I think the main feature that the new one will, or next one will have. Besides that, will be like just improvement and bug fixing. Let's see how long we want to make the cables here. I think something like that. Because like there will be another connector here, I don't want to like stack the things or the cables too much. So maybe we just do it like this. I do not have a device with standing island yet. That would also go. Oh, you can still use the live activity, right? That's for all iPhones. Like also still have an iPhone 12. I did not upgrade in quite some time. Oh, time for our most favorite thing in the world, crimping JST connectors. Wonder if we can kind of combine the two to make the fan whole again. We cut off the little noses. I also have the 12, which will be great for stressing. And it would be great if you have the newer form. As far as I recall, you can even reuse code from widgets for that. And it is a widget. The live activity, or like the dynamic island stuff, and the live activity, like the notification on lock screen, that's the same. It's just different visualization of the live activity. And you build that as a widget basically. It's just a fancy widget that has some extra skills basically, or like some extra features. That's really all it is. From the code perspective, like widgets, it's exactly the same. Also like for iOS 18, there will be this new control center control thingies, like the toggles and stuff. I need to see if I can, oh wait, DuPont, we need DuPont, we don't need JST. To see if I want to support it or can support it. But it's also just widgets. It's all the same. It's pretty cool. Also the shortcuts app, like this app that is on iOS pre-installed, that's using the same data framework as widgets as well. So I also added support for shortcuts. So you can create like shortcuts. Like I don't have my iPhone with me because it's filming me. But can I? Oh, I don't have it here. But yeah, so basically you can also create now Octo app shortcuts, which is pretty cool. So you can automate stuff when you leave the home, turn off the printer. But nobody does, of course. I always forget which size I crimp those. I think the DuPont are the smallest in my crimping pliers. It seems to be okay. If you crimp, I think JST on the smallest, like you crimp them off, like you just break the wire. 2 more to go. Then we also need to figure out what cable is what, because I have no clue. I mean, red and black are clear. Actually, Jonas, if you want to check it out, give me a second. I can just post the link for the test flight data. I think I had that anyways. Okay, I don't have the link right now. If you just send me an email to hello@octoapp, I'll just send you the link. Just send me an email and then I can send you the test flight if you want to check out the widgets and stuff. Always nice to have somebody testing. So let's quickly, I mean the red and black wire is clear, so the black one is bottom. We need to squeeze it a bit more. Okay, and the red one is the topmost. So these two are easy. The other two we need to kind of figure out quickly. Let me quickly. I have all the crimping stuff. Between me and the laptop, which is not really handy. Okay, so this is the 15 fan, that's what you see. So this is basically what I ordered. Notice the slower one. This one. Does it say here what the pin out is? Here, blue is PWM and white is the speed signal. So blue is PWM. Oh, I also made a mistake. PWM is the top one here. VFan is below. Let's see if we can rescue this housing. We can. Okay, so the red one is the second one. And blue is PWM, so blue is on top and white is in the middle. So that's our pin out. Here is our cable. I think it's best to put this below, so this is the bottom one. Then this goes on top of that. Just a lot of cables. And now this is the problem basically. So this one we need to extend. Like I already checked, like there's not really like a way to like route it more efficient to get like extra centimeter of cable here. So I think best is to just extend it. Get this out of here. So I'll just cut off the top, and then conveniently we have black and red wire here. So let's just add a little bit here to extend that. Sorry, Nickman, no worries. I just mentioned, if you want to check out the widgets, you can send me email to the address in chat. Then I can send you the beta invite link. So, soldering. We did a lot of that last week. Let's just hang it here. So you can set it up. And then I also have this fancy filter, which we should use. Okay, and before I forget that, let's add a bit of heat shrink on the 24-volt wire. Let's just push this down, that doesn't accidentally shrink. And then we can use slightly thicker on the, basically package everything up. Like you can also cut them in a staggered way, but I kind of don't like that. I prefer just having like one heat shrink and then like one heat shrink around everything. I just heard stuff about leave your home. When I first got my China plugged into smart home outlet, I said to set up the automation shut off when I leave the home. Yeah, it's actually I also have stuff like that set up. Like not that I leave that it shuts off when I leave, but if the printer consumes less than 15 watts, something like that, for 15 minutes or 20 minutes, I shut off the printer automatically. So basically like 20 minutes after the print is done, the printer just shuts off automatically, which is like really nice. And I set up in Home Assistant. So basically that's, hey. Oh, there was the tip that doesn't hold. This tip is a bit broken. It doesn't want to like have solder on it. I can clean that a bit. Okay, should be fine for the 4 wires. I think I just need to order like fresh solder tips in general. But yeah, like adding some automations to printers is really cool, I think. You could also like change the lighting if the printer is done or something. If you use Home Assistant, there's integration for Octoprint. For Clipper, you need to use the API, I think. But yeah, you can do like a lot of cool stuff. That was soldering for now. Who totally freaked out when I left the house for the first time and closely monitored the app over Octoprint with like 3 min after leaving the home. Just randomly disconnects. Oh. I'm not quite sure. Like from my side, the stream looks okay. YouTube says very good connection. I don't see dropped frames. 0% drop frames. Not quite sure. Like I have this like status from YouTube where it tells me stream quality and it doesn't complain about anything. So I'm not quite sure if it's me. Now it's black. Let me see if I can stream my stream. Maybe there's something on YouTube, I don't know. Where do you see my... Also bad stream for Steve. Yes, also I'm trying to play back my stream right now, like, and it doesn't load at all. But I wonder why. Like, it all looks fine on my end. Huh, weird. Sorry guys, I'm not quite sure what the problem there is. It might, like for me, like I'm just trying to load the stream on YouTube right now and it just doesn't do anything. So it's definitely not only the two of you. Weird. Yeah, and other streams load up instantly. Like if I just check out like random live streams on YouTube, they all load. It's just mine that for some reason doesn't. What I can do is I can quickly stop streaming for like 30 seconds and just reconnect to the stream. Maybe that solves something. Let me do that. So I just stopped streaming. I'm just not sure if I manually stop, if I can reconnect. Quickly see if I can just cut my network connection accidentally. Okay, let me do that. Let me just unplug the Ethernet cable. Okay, see you in a second. Not sure if that did something. So basically just unplug the Ethernet cable and turned off Wi-Fi. No Wi-Fi cables here. I'm not quite sure if this helped. Let me quit OBS and reopen OBS. Let me do that. Okay, let's try that. Still good on your end. Okay, let's quickly wait, because I'm a bit scared of like playing around with the stream while streaming. It's also only like 2 people watching, so I guess it's Jonas and Steve. So Steve, any improvement on your end, or still bad? Oh, I don't have a... It's not dropping now. Okay, then let's just see if like something changed now. Okay, I quickly need to grab a lighter. I don't have a lighter here. Give me like 5 seconds. Right back. Switch around the stream call. You want to switch to 1044p? It's not working. Okay, weird. Then maybe it's really a YouTube issue. If like they have problems with like down sampling the stream or something. Oh, here we have our very beautiful new long table. I guess we need something like this. So let's crimp 2 more connectors. I think here it's like, yeah, it's 5 volts on the inside and ground on the outside. Now we really make use of, well, now this connector is free, but we make use of a lot of connectors here. Yeah, back to the image. I quickly learned that you should not automate to turn off your printer and expect to continue printing. Yeah, I also had that learning very quickly. It's also like, don't click the wrong button. It's very devastating. What I actually did, again, like I'm not quite sure if you use Home Assistant or not, but I have basically the smart switch I have it hidden, so I don't use the switch directly. I have a virtual switch that runs the automation, and the automation checks if the printer is consuming any power. And if it's not consuming power, then it shuts down the Pi, and after it shuts down the Pi, it will like switch off the plug. So basically there's this extra check in there that the printer must not consume power on the smart plug, which is also not perfect because turns out if you don't plug the printer into a smart plug for some reason, it still turns off the printer mid-print. So if I have time at some point, I want to change it to use the Clipper API to really like connect to the printer and check if the printer is printing. I think that's the only good solution. It's just a shame because like for Octoprint there is the is a real like Home Assistant integration, which makes it really easy because then it's just like directly in Home Assistant already. So I guess it's time to dual install Octoprint on this machine here. I wanted to have one Octoprint printer anyways again. So maybe we can do like a Clipper Octoprint or Octoclipper on this one. Oh wait, that's the wrong. We need 4. Here we go. We need one with 4. And then it's power on the inside and around on the outside. Sure if that's now it's in. Or maybe we can even route that like completely on the outside. Let's see if we can just push this here in the corner a bit. Like, stays there. Yeah, this one is now, it's a tad too long, like I should have cut it like a tiny bit shorter, but we can kind of squeeze it in. Cool. You see that this is somewhat properly tight. I kind of like this. So basically I had the fans lying around and I just printed the housing basically, and I ordered these filters for like €5, three pieces. And this works really great. No regrets building this. So let's quickly make some space. Main set plugin for Home Assistant would be great, yeah. And, I heard from somebody that they want to do that. Quinn from Octo Everywhere mentioned that he maybe wants to make a Home Assistant plugin for Clipper. Because he also has the, so there's Octo Everywhere, and then he has the side project is homeway.io, which is basically Octo Everywhere but for Home Assistant. And he kind of has that already kind of both sides of the equation, and he wanted to maybe make a Clipper plugin, but I'm not quite sure if he still plans on doing so, or if he ever considered it. He just mentioned it. But that would be pretty cool. Like, that's really needed. Do you have a link? I need to build this. Link to what? Cannot use Octo Everywhere, just use tail scale. Yeah, I also have tail scale. I think like what you get with Octo Everywhere and Obico for that matter is like the failure detection. And it's like all a bit neater, like easier to set up maybe. But I'm really happy with tail scale. I use it for everything actually. Like I don't use local network addresses at all anymore. I just use the tail scale hostname. This other thing, yes, let me quickly check it for you. It's a really old model. It's like from 2015 or something. I think it's just on printables. Fume extract. So there are quite a few. Like there are quite a lot of different ones. I was just looking for something that is simple. And for what I have, the parts mostly. Here, this one. I just didn't print this back part here. And then it has like the vent hood, but I have the small one. So basically I have this, but in the tilted version. I'll just drop the link in the chat. So, okay, so technically we should be able to turn this on. And configure something with the fan. I built a Postgres proxy so we can use Tailscale users as auth mechanism for the database work. Oh, that's cool. we use it also at work actually sometimes, because we have some, I'm an app developer, if you would have guessed, and we have some testers in a different country. And sometimes it's really because they have different test devices than we have in our office. And sometimes there's an issue that only is present on one of the test devices. And then on Android, basically what you can do is you can install the Tailscale app on Android, and you can access so basically you can connect to the device via Tailscale using the Android debug tools. So basically I can sit in Amsterdam in the office and can use a device in a different country to debug, which is pretty cool. That works really well actually. Oh wow. Not sure if you can hear that. This fan is the polar opposite of this fan. Okay, I think we have to configure the fan to turn this off. Do I have something to put over that? Okay, really sorry. Let's be quick about that. Let's be quick about that. Oh, it's not that loud. Oh, do I have the... Oh yeah, I have the noise removal on. Okay. Sorry. Let's be really quick about that. And I stop talking, then you don't have noise artifacts. Okay, we need this. I sorted my configs, but I think now it's I don't find what I need. Yeah. Not too bad, okay. So we need GPIO of 15. This doesn't work. This should not bother us. Mm. What did we do wrong? It should be PWM. PBO 15. Okay, let's quickly turn off. I'm just thinking because like, we had the problem with the RGB where the part was defective, so maybe we have the same problem with the PWM signal. If you have minutes, you can let me know where you source the filters. I source the filters. I mean, it doesn't really matter. Like it's very generic. Like you just need a 13 by 13. I got them from Reichelt, which is like a company in Germany, but they deliver like all over Europe. I'm not quite sure where you are. Yeah, it's this one. But you also get it on AliExpress. Oh. These are the ones I got. So they're like pretty cheap. And it's like a set of 3, basically. I mean, it's just those like square filters. It's a very generic part. I think you will get it on many different web pages. They even have different ones. Yeah, you just need to check the size, but I guess if it's like bigger, you can always cut it down. Yeah, so like these are the ones I got. Like not this. These are the ones I got. We also just dropped it in the chat for you. Heater fan is hotend fan. Heater fan is the hotend fan. Yes. So basically, the heater fan is the bottom one. This one here. So I think. Or am I not mixing something up? The fan is the part cooling fan, pretty sure. Let me just see, like if I miss something in the configuration, but it just says you can set hardware PWM, but that's not required, right? Then it's just using software PWM. Then I mean, we can quickly configure that, I guess. The tachometer. I think it was 14, 12. Tachometer is 12. It's like no matter where I put the chat, like it's always in the way in a certain sense. Maybe I need a shortcut to hide all those like side panels here. So that is 12. But what is in pin? Am I misreading something here? Oh yeah, I think pin needs to be the PWM pin. Optional pin to enable power. Oh, yeah, we have it wrong. This needs to be 15 and this is doesn't. Now it's correct. The pin should be that. Okay, let's try again. Close your ears. Okay, something is not right. Something is not right because like firstly it doesn't report any speed, and secondly it's always on. I'm in Germany, it's right, it works perfectly. Yeah, then that's a good thing. I don't think the shipping costs in Germany are super high. Okay, so why wouldn't it work? Steve, no, I'm wrong. Sorry. Yeah, no worries. I think it's you also sometimes have to get something wrong, right? Okay, so but the enable like the enable pin was fluke of mine. So the pin should be pin. So the pin is correct now. We set the pin correctly. Parameter must be provided. I'm not quite sure if there's something. Flipper configure for pin. Fan. $5 I can get 10 for 15 on Amazon with no shipping. Well, yeah, that's what I mean. Like most likely it's not the cheapest address. I only ordered it at iTilt because I also ordered like some electronic parts. I ordered the steppers we used, the stepper drivers we used in the last video. Let's see. I just want to see the config. So we have to. I mean, this is a temperature fan, so the configuration is a bit different, but it's just the pin. And hardware, the official PC fan specs call for. Okay, I don't know if this is super important, but we can configure this. And then there's this little like pull up. Let's try this. So firstly, like here, the person inverted the pin. Not quite sure if this is important. Let's try the inversion. Let's try the little pull up, and then we can also try the hardware PWM through and just like set this to 25 kilohertz. Here we go. It is quite, like there's a lot of air here. Nope. Yeah, so that still works. Okay. So I think, I mean, configuration, it should do something at some point, right? So I'm just confused because it neither picks up the RPM, nor does it like do anything with the fan speed. I mean, like worst case, we can also just not drive this via PWM, right? Like we can always just do it on voltage. But it's just a bit weird. Because I do not expect this to be difficult to configure. Let's see, is there any other information in here? So there's also nothing here on how to configure it. Let's see. Yeah, I'm just concerned that like there's also something broken on the board for that. Because there should not be much to it to configure. Where are we? We're just clipper config and some random clipper config. So I don't think we didn't configure this PPR value here, but I think that just defaults to 2. So this config is the same. I mean, it's just a random pin. We can play around with the cycle time, but the cycle time like off should be off. So cycle time should not be the problem. Because yeah, it would just like then it would run choppy or something, but cycle time is not a problem. And then pin is just the pin. I just wonder. I mean, the GPIO pins here we definitely have correct. So it's GPIO 612 for the signal, and I can't open it now. And VFan PWM 15 and tachymeter is 12. So I don't think there is anything that can go wrong there. So I'm just wondering because like this part was broken. Like this is the part that was broken for the RGB header here. We do have the same part here as well for this section. So I wonder if we have the same defect here as well. I'm just not sure what that would cause. I mean, those two here, I'm just assuming like these are the transistors that control the PWM here. So this seems to work, right? Because we can control the fan speed on these. So that's all fine. I mean, I think I can control the fan speed. Yeah, like we checked that, like this was working. And then here we have this logic level shifter again, same part as here, and then some diode and whatnot. So potentially this part is also broken or caused issues. So I'm not quite sure if we should also try to just bypass that. But I think like if it doesn't work, like technically, like if there's no PWM signal, right, the fan should just be off. And now we have like constant on, which is semi-annoying. Let's do the following firstly. Let's pull it off. Let's use jumper wires. to connect that. Because in A, we can measure a little bit on the voltages, and B, we can also just unplug the fan so we don't have to shut down the Pi, so we can talk, or like I can talk. You can type whenever you want. Let's see. You sent me something on Discord. Let me quickly open that. Yeah, so that matches what we have. Never connect to 12 volts. The blue wire, yeah, that is not recommended. Here we go. So pin is not, and then the pin. So the not we now have. Shutdown speed, that's not important for now. Kickstart time, it definitely works, so also not really the problem for now. Tachometer pin has the pull-up, so that's something we now added. We didn't add the pole interval, and PPR is defaulting to 2, hardware PVM. Let's see, cycle time we set, so these are set. Yeah, but the cycle time, like, I don't think it's the problem. Because like, it doesn't turn off. Do not connect fan positive and ground to a controllable port with PWM on another controllable fan port. Yeah, that's how you break it, so you don't connect it. The cycle time is at 25, but the things like for cycle time, that I know, like from my experience, it just like doesn't run smooth if you screw up the cycle time. Okay, let's quickly like pull it off. Let's. I of course don't have jumper wires here. I quickly have to grab those. And how do we do that? Let's quickly also double check that we have it connected correctly while we have it off, right? So this wouldn't be the first time that I screw something. No, PWM is blue. Blue is on top. Tachometer is white and is below, and then we have red and black. So the pinout is correct. Do not trust any jumpers. I'm not planning on doing that. Let's quickly double check here. Red positive, black negative, blue PWM, so that's all fine. Here's some dirt here. Yeah, I'm just wondering, but I guess like it's easiest to just connect the jumper wires directly here, and then we can like figure it out this way. Let me quickly grab jumper wires. Be right back. Okay, here we have my bag of random cables. We need 4 conveniently here. So back to the most favorite thing, running jumper cables from this very beautiful port here. Let's see. So we have black ground is the top corner. Then 24 volt, let's say the purple one is 24 volt, is the bottom one, I guess. I mean, like, reading this here is V fan. Yeah, must be V fan. So that would be the bottom one. And GPIO 15 and 12 are, oh yo, that will be tight. Because like the connector here has a smaller pitch. I'm not sure if I get all 3. Yeah, I don't get them next to each other. There's not enough space. But we can squeeze it in here. This is the maybe. Yeah, it just barely works. I hope I don't bend it. Black is top. Okay, let's double check that. Ground is the top. Then purple is 24 volts. And then 15 and 12 on the bottom. Let's quickly do the following. Let's just double check what we were doing here. Okay, off we go. So, nice and secure. So now we should have, let me just see if I can place it. I can't really read that, right? Between the purple and black one, we should have 24 volts. Which we do. So that is 24 volts. Now the white one is a PWM signal. So it's like, I'm not quite sure if that makes sense, but it's 3.3 volts, which makes a lot of sense actually. So this is just on, right? So we see 3.3 volts on the PWM signal, which means it's just on. So the thing is basically like, because I'm not sure if the board here works correctly. Now the board is bypassed and we get 3.3 volts on this. On the thing here. And if I understand PWM correctly, 3.3 volts means it's 100% on, which is incidentally what we see, or hear, to be more precise. So let's just see if we can convince Clipper that maybe we should turn this off. Let's start with the following. So this is GPIO 15, right? Which is the bottom one. Yes, it's a white one. And we measured 3.3 volts there. Let's see if we can configure a GPIO pin, just in plain GPIO pin with this thing. So for now, let's just, I mean, it doesn't really matter. We can just change it back to GPIO 14. let's just see. So this is GPIO 14. So we just basically change back to what we had. Then we just do output pin on EVB GPIO 15, which we call test. Let's just restart that. Now we should have just like a test pin. So it's not a, yeah. 50-50 chance. 50-50 chance. So it's GPIO 13 here. So 14 is the other fan. It's the heater fan, hotend fan. Let's try again. Here we go. And we have a test, which is off. I mean, not quite sure if that makes like huge difference now because the fan is just a fan, but less fancy configuration maybe. And I think it's off. Wait, a bit hard for me to see actually. Yeah, now it's off. 0. Let me turn test on. So I just put it to 100%. And we have 3.3 volts, so that the hardware works correctly. And now technically if we should put it in the middle, like, because like a PWM signal, the multimeter should just give us like something 1.3. Yeah, perfect. So the hardware control works as expected. So it's really a configuration issue we are facing here. It's a configuration issue. Okay. Let's check the sample config here. Maybe we should have done that before. Fan. Here. GPIO 15 and GPIO 12. That's how they configured it. EVB can is for me just EVB. So, I mean, let's give that a shot. So we now know this works correctly. Let's just use the same hardware PWM here, true, and the same time. And then this becomes EVB, and this becomes EVB. This is removed, right? Cycle time needs to be removed, and now this is correct. Let's quickly double check that. So 1512, 1512. Kickstart time doesn't really matter for the fan right now. Okay. Let's try this again and see if we can just like control the voltage. Okay, let's just put it to 100. So now we should have 3.3 volts. We do have 3.3 volts. Let's put to 0. And we do have 0. So I'm not quite sure what I now changed. That's exactly what we had before, right? Or am I missing something? Now it works perfectly, 1.4 volts now. Okay. I'm not quite sure if... Like this now works perfectly fine. Let's turn this off. Fan is off. Let's quickly just connect it. Which is fun. Always connect live wires. purple is... Yeah. It's off. Almost. It doesn't shut down, but it's off. Yeah, now it works. Now it works. Yeah, really a lot of air. Okay, let's also try to fill in the tachometer. Okay, now let's see if we turn it on, if we now get any response. Okay, so tachometer doesn't work. Which, not. Oh, it also turns off now. Before it didn't quite turn off. Now it's off. Yeah, it's completely off. Okay, so this works. Then the question becomes, if we now plug it back in, does it still work? If it doesn't work, then it's a hardware issue with the board. But then basically the fix would be the same fix we had before, which would mean we remove this component here, which is easy to do. We can quickly do that. I have all the tools. So we remove this component and we run the same jumper wire as before. Same we did last stream. So I don't know what it did with this board to make it this angry. I think like what happened maybe is like one time I might have misplaced this row by one, like the plug by one. It's really tiny. It's really easy to plug it in incorrectly. So you really have to pay attention here. And for some reason, like this fried those two. Like you see basically here, not like I can zoom in or something. So here we remove this part, and that's the same as here. And I'm pretty sure, like this is a logic level shifter, which shifts from 3.3 to 5 volt logic. As far as I understand, my understanding is very limited. Similarly, you don't really need this part. So the LEDs and the fan seemingly both can handle the 3.3 volt logic fine. So we can remove the part and just bypass and connect the pin straight to the plug on the back side. Let's also quickly check on the schematics of the board what is involved with the tachometer signal, if there's some resistor or something we need to make the tachometer work. But I think we are on the right track here. I'm quite sure why I didn't consider like just checking the config right away, but like it was such a simple thing to configure. That's did I close the wrong one? Hardware. Where's the schematic? Ah, here. Schematic. Let's find the 4-wire fan. Here, this should be 4-wire fan here. So we have the speed there's no 4-wire speed. I'm not an expert in reading those. So these are directly connected, so that's the ground and the power. Then we have speed and 4-wire fan. So we have 4-wire fan, and this is this logic level shifter that I mentioned before, which is the part that was broken for the other one. This connects to 4-wire fan, so this goes here. And this goes to 4-wire fan PWM, which I assume is on the plug. Man, like naming, just keep the naming the same, please. 4-wire fan PWM. So basically this part sits in between the PWM signal that reaches the fan and what we put in on the plug. So I'm pretty sure that this is broken, but from our experiment now, basically we can just remove this and bypass. So we just connect the 4-wire fan PWM directly to the 4-wire fan. So the question is now the 4-wire speed. Is there anything with 4-wire speed? But I don't think so, because this directly connects. So for the speed, there can't be anything broken on the board. So that might be configuration issue or something else. Let's solder some boards, right? Let's remove that and just bypass it. Oh, let's try, and then let's not jump the ship. Then we quickly shut the sound, then we can like plug everything in peace. Okay. It's definitely cool to like try to troubleshoot these issues. Like, I think it's a useful skill to be able to like at least like understand basic schematics. Would not have imagined that I start doing that, but hey, here we are. So let's just secure one screw here. We will know very quickly if it works or not. Like if the fan stays on, most likely will turn on right away. Let's see. Okay. 3, 2, 1. Nope. Nope. Solder time it is. Yeah, it's most likely exactly the same part that's broken or not working. I don't know if there's just something wrong with this board, but I think the LED worked initially and then at some point it stopped working. So I'm pretty sure like I broke it in some way, but I have no clue what I did to, I mean, maybe I misplaced the connector. But it's about the only thing I can imagine that I did to the poor board to make it so bad. Let's see. Just try to make a bit of space. Okay, we need my hot air gun. 1 second, I need to grab it. we have a hot air gun. So, I also just saw like I kind of melted my wire a bit here. That's very good. Need to, like, it's not melted through, so it doesn't really matter, but not a good look. To be honest, maybe I should just route it under the table, because this is kind of like, let me at least route it the outside here. I need to have some guard when I put it down. Okay, let's disassemble this. Where did I put the Allen key for that size? You misplaced connector when the Nomi was working, then when you plug in correct Nomi, it is still working, I remember correctly. Yeah, something like this. I'm not like trying to deflect any fault here. Like, I'm pretty sure like I broke it. But yeah, like this connector, I don't think it's a good design, to be honest. Like, it's so easy to like put this in wrong. Like, there should be some guiding feature to guide that in, like to just prevent you from making the mistake I did with like just like putting it in wrong. But it's also interesting, like if you just look at the schematic then. If you look at the schematic, like if you mess this up, because I'm like, if you shift it left right, it doesn't matter, right? Because then just one row of pins is not connected. Well, you have ground on both sides. So most likely, even if you just plug it in like left shifted, like you can still make some form of circuit somewhere. Which would be fun. Probably send 24 volt and 5 volt. Yeah, but the thing's like everything else works, right? It's just this like logic level shifter that doesn't work. And the 5 volts, I mean, potentially this is next to each other, so I could have done that. Yeah, potentially. But yeah, there needs to be like some way that like it can't mate. Like maybe this is not the best plug for that. I don't know. Like it shouldn't fit in if it doesn't fit properly. But yeah, it's a different. It's like the board itself is not very expensive actually. Like you can buy a new one for like 7-8 euros. So it's not that horrible. It's just like, yeah, not the best. I mean, maybe even the stealth burner could have like some keying feature here already, because like it's kind of designed to have these like toolhead boards with this connection. It also just, it never happened like with the old one I had. Here, this is the old board. The thing here is just, it's only like 8 pins instead of like a million. That's just the difference. And this is like the larger pitch. So you need to like misplace it quite a bit further to like cause the same issue. It's just like, it's just bigger. So it's like not as easy to place it like this. Whereas this one is just like, it's like such like, it's like less distance. Yeah, it's just like way easier to misplace this. Maybe they should have also maybe not used one connector like this, but just have like two connectors, one with only power and one with all the GPIO. That basically like you have, even if you misplace it, like you cannot create like a circuit basically. But yeah, that is besides the point. Let's fix what we have. Yeah, and here you see this is the jumper wire we ran last time. So basically we do the exact same thing. We remove it on the front, the part, and then we run the jumper wire on the back. But potentially that's also why we don't get the fan signal. It's just like something is broken. Okay. I'm feeling confident that the connector is far enough away that we don't melt it. Let's hope I do not regret this decision. Let's actually don't take any chance. And I'm just adding like a bit of electrical tape over it in the hope that it will protect it a bit. I'm not sure. I do have proper captain tape, so maybe we should even... Yeah. Let's just do this. I hope the electrical tape doesn't melt in like a horrendously bad fashion. Maybe do it like this and have a bit better angle. Oop. I'm burning a connector. Okay, wait 1 second. I never burned one of those. That's never happened. You kind of have to hold it like in a bit of a position. Here we go. Okay. Whoop. I mean, it's easy to replace. It's also still functional, so it's fine. And the big plug. The big plug survived. That's the most important thing. Okay. Then let's see what needs to go where. So the PWM is the topmost here. So this is the PWM, and I think we need to go here to the bottom. Let's just quickly confirm that. Let's just quickly check that again. So the RGB. Oh no, it needs to be directly below the RGB. The RGB is the two from the bottom, and then this one here on the corner is basically the one we need. So the RGB comes off here, and then this one is the PWM. So basically we need to run a cable up here. I don't want to like cross them, so I'm really just gonna like run it around. I guess this sticker we can also remove. Let's clean this up later. So from here to there. Let's see. Yeah, let's just use the black cable from the fan again. Or let's actually use blue. So this will kind of go from here. Can make it a bit shorter. So actually I think we should not make it like too short. It'll just be a bit easier to solder if it's a bit longer. So something like this should be fine. Let me get this gooey stuff off here. I still forgot to buy Q-tips, so. Here we go. Oh, I totally forgot my fancy filter here. Let's quickly just a tip off, and let's also add a little bit of pin to the ends. If I'm smart, I'm also using tweezers. This doesn't want to quite go where I want it to go. Yeah, the solder. I will order solder tips right after stream. Like, this is not. Okay, let me try this one more time because I don't like this. Okay, now it's a bit better. And then we just do a loop all the way to the top. And our second jumper wire is born. The isolation here is a bit broken on this cable, which I don't like because it's very close to this pin. Okay, let's quickly replace. Let's try this again. Let's try it again. We need to be a bit quicker with the soldering. Yeah, if you like this side of the tip, I'm not sure if you see it. There's like a black spot, and like the pin doesn't stick there. This side is better, so. Much easier. Now I cut it a bit short. Yeah. Still works. Kind of goes between the points there. But add a little bit more. And up here. Ah. Okay, the isolation is breaking really fast. All good things are threes, right? Let's try again. Maybe I try, like if it now doesn't work, I try a different cable. Yeah, the isolation is just like melting immediately. Yeah, no, it's the same. Okay, let's try a different cable. Maybe this is not the best for soldering. Let's use. We have the same one that we used last time. Not here, I think. I do have red cable, so I mean, who cares about colors anyways? Let's try this. This is PTFE, I think. Should be much better. Yeah, that is better. If I don't get this soldered here, we might have a winner. Just add. Not sure why this doesn't want to. Well, now I'm bridging pins. Very elegant. Not sure what the problem now here is. It just doesn't stay. Now it's kind of, but I don't like how it's soldered. Let's just add a bit of fresh solder. Okay. Yeah. Oh. Oh. Okay. Now it looks okay. It's quite high up. Okay. One last attempt. Okay. Now it's nice. Success. I mean, you don't see anything because nothing is in focus, but hey, we have a jumper wire. It's very adamant on focusing on the... Let me quickly check what I have here. And for some reason the focus today is a bit weird. Here you go. We have a jumper cable. So that should fix the problem that we diagnosed. We did melt this connector a bit, but it should be fine. Let's also quickly clean up a bit on the front of the board. I will order Q-tips and I will order, I will buy Q-tips in the local store and I will order soldering iron tips. Just cleaning a bit. We are cleaned up. Let me quickly put away some tools. And then we can attempt to assemble that. Create like a pile of trash over here. Oh. Okay, let's just quickly confirm that what we did is correct. So we had the bottommost on the side where also the RGB is, which is correct, and we bridged it to the topmost of this connector, which is PWM. So this should be correct. And then we can just put it back in here. Oh, wouldn't have needed to clean this one up. I did not expect this fan to be such like an operation, but I guess by now I should know better. Okay, let's put this one in here. So I'll try to like squeeze this back in here on the sides. Then we have the RGB. We have, put this below, we have the 4-pin fan we're working on. And we have this fan. Okay. Everything is well packed. Very careful. I think it's very easy to shift up or down. Like up or down is very easy. Left or right is very hard to like misplace. So if I shifted something, it's up or down. Most likely up, like one up. And that would have done it shouldn't have done anything, to be honest. Oh, this would have put 5 volts on 24, or 24 on 5, yeah. So most likely that's what happened with the connector. 5 volts on 24. But it's also like curious that you still get the screws in. Yeah. Okay. Here we go. So let's turn it on. Let's see what happens. The fan is not on, which is good, I think. Okay, we have working RGB. Do we have working clipper? Yeah, we have working fan. Not sure if you can hear it, but it's working. Also, like at very low percentages, it works very well. Like usually, I guess it's a benefit of having like a 4 or 3 wire fan. Like 5%, I can still feel like very slight amount of airflow. So you can very finely control it. Woo, cool, okay. I'm not quite sure if you can do something about the tachometer not being picked up, to be honest. Like it still shows 0 here. I shifted one up also, but I saw it before turning it on. Yeah, lucky you, Jonas. But for me, it's also like because I'm sitting here, like not trying to find excuses, but like this is not the most natural like position usually because I have to align everything with the camera. So for me, it's like super hard sometimes to do stuff here. So if I would work on it, I'm also like, I had the printer directly here in front of me, and like it's easier to spot such things. But yeah. Okay, let's see. We check devices. So the tachometer pin is now configured like it is configured in the just close all the things we don't need. So tachometer, 4-wire fan. It's just they don't have anything. They do have the PPR with one commented out here. Oh, sorry, you don't see anything I'm doing. So let's just try this PPR. I don't know if that does something. Let's restart that. Let's also maybe Clipper fan config. Let's just quickly read up if there's anything else that we could configure. That's not what I wanted. Configuration reference and we actually can also configure shutdown speed. Then basically, like when the printer has a problem, it turns off. Because for the hotend fan, that's fine. What else? Hardware PWM is configured to true. Kickstart time is fine, I guess. Like it turns on, so the kickstart time is fine. I also don't think we need the kickstart time really with the 4-wire fan. Like the fan should take care of that, I guess. Off below is fine. We don't need it. Tachometer pin is what we're working. PPR, when tachometer pin is specified, is the number of pulses per revolution of the tachometer signal. For BLDC fans, this is normally half the number of pulses. Default is 2. Okay, let's just try to play around with the number. Maybe that's the problem we have. And then the pull interval specified. This is the poly period of the tachometer pin in seconds. The default is 0.015, which is fast enough for fans below 10,000 RPM at 2 PPR. This must be smaller than 30 divided by tachometer PPR times RPM, with some margin where RPM is the maximum speed. Let's math that. So 30 divided by tachometer PPR is 1 times the fan speed is 9,200. Fast enough for fans below. This must be smaller than whatever we get here. So I get at the moment 0.0032. 0032. So this is like double the value. So that should be fine, I guess. Okay, so we set the PPR. I'm not going to restart again because I just set the shutdown speed. Yeah, but it still shows 0. Let's see, Honey Badger 4-pin fan. Is there, maybe we find some configuration hint somewhere. Not really. But I guess like the things like we're just getting 0, which is like really weird, right? Like if it would just be like wrong setting, I would expect like something to show up, but see if some shop somewhere has some information, but doesn't really seem like it. Okay, I'm not really like, I don't need that feature, so let's not spend any more time on that. That would have been nice. Now it's 99% nice. So let's just comment this out. Delete those things we don't need. Let's just put it to the bottom and then let's call that the win. Whew. Just quick double check. Yeah, now it works, and we don't have the feed anymore. Cool. So what I would do now, I have this like weird print here. Let's actually quickly slice something up. Just like a really simple test. Just quickly, I have to link this up. Not what I want to. Here. Yes, let's just do. That's what I did last time. So I just use a cube. Rotate that by 45 if it wants to. And then add the negative part, cube. Center this, which means it's on top. Rotate 45, and then I just pull it up. We just have like a V shape. Now we just put both down. Slice. Now we just have this like very stupid, simple, fast overhang test. So we can just print that. I just need to make a bit space to put the filament. And we can just see if like we use Form Futura, easy fill. Crack this open. Cool. And I still have to like print some form of. Sorry, you just see my elbow now. I need something to hold this the end of the golden tube here on the side. Super annoying. Alright, and there's still a bit left. Okay. Let me just quickly put the temperature already up to 200. The bed to 55. I'll quickly have to pull out this like teeny tiny bit of filament that's there. For some reason I forgot to pull it out. Oh, this is the wrong printer. This is the bug in Orca Slicer. This is like furiously annoying. Like now it's controlling the V0. This is not the printer I have. Oh, okay, my bad. I selected the wrong printer. Okay, I mean I could have seen that, but let's try again with the correct printer, right? Let's quickly turn off the other one. My bad. Sometimes like when you switch the printers in Orca, it sticks with the previous printer. It doesn't change or like reload the web interface. But this time it was squarely on me. Squarely on me. Let's quickly wait for this. But I guess technically we can let's really wait for 200. Let's just pull out the filament. And then it can do its homing thing and everything. But what we can do is, while we wait, right? Just sprinkle some of the IPA. Get it like pretty clean. So let's see. Yeah. Oh. Could have cut it like even shorter. That would have been even easier to get it out, I guess. A lot of sarcasm here. Yep. Okay, let's print that. I mean, it would have, looking at it now, like it says switch wire there, if it's a switch wire, and the band is a little bit bigger, so I could have seen it. Okay, the band's already on temperature, basically. Isn't it beautiful here with the LEDs again? Let's see what our fans can do. Already tons of like stuff again. It's amazing like how quickly printers get dirty. Let's wait for the hot end. Ignore the mess. I'm definitely not having like the most cinematic background here for sure. Like it's like tons of cables here, tons of cables there. But yeah, it's the best I can do at the moment. I actually like tearing this entire thing down every week. Except for lamp, the lamp stays there. But yeah, this is also my dinner table basically. So I have to clean everything up. And that thing in the back I built like a couple weeks ago. It's just like one complete stand with all the stream stuff on it. So I can just carry it to the storage room in one go. Fans kick in. Uh-oh. Heat extruder. Well, It seems like the fans are cooling too good. It cooled down the nozzle so much that Clipper said like the heater is not heating as expected. So let's do the following. Let's do a pit auto tune and try it again. Okay, this is the first time something like this happened to me like in forever. I actually never had like a shutdown because of fan cooling. Okay, let's quickly do pit auto tune. So let's set the fan to 50% maybe, I don't know. Let's do 66. And let's quickly do let's quickly do that. So basically we just calibrate the extruder. We calibrate the extruder while the fan is running at like halfway. So hopefully this will give us a result that works with the fan off and the fan on the full tilt. Not the most interesting. And it also heats way slower, like usually the nozzle heats quicker. So it really has an impact. Interesting. That's as interesting as watching paint dry. Let's see. Almost at 250. Like it really struggles. It really struggles to get up. I think I cannot print ABS with that anymore. It won't hit like 250. It's crazy, like when it stops heating, like it immediately drops. Like temperature really drops when it stops heating. So just turn the heater off and like within like 10 seconds it lost like 10 degrees. Hit calibrate interrupted. Heat extruder not heating at expected rate. See the verify heater section in docs. For parameters that control this check. Oh god. Where are we supposed to check? Config reference. Clipper config reference. See? Pit. But so now basically it tells us how to configure that. But I want to measure that, right? So it's a bit odd that while measuring it craps out. Let's try again. Let's put the fan to 30% and just see if we can like get it stable at that. Let's just put this to like 30 and try again. In the meantime, let's Google heater not heating at expected rate clip during pit auto tune. Okay, let's also check what this check gain time does. Maybe that's interesting. Wait. Check gain time. This controls heater verification during initial heating. Smaller values result in stricter checking and larger values allow for more time during initial heating. So this is the only says initial. As long as the heater increases in temperature within this time frame, then the internal error count is reset. Okay. Let's see. Gain time, minimum temperature. It says that the heater must increase by during the check gain time check. Okay. And then there's the max error. I wonder whether we can just suppress the pit while we do the pit auto tune. That like the pit auto tune doesn't fail because of pit like heating error. But now it seems like it does the cycles. Now it seems like it's doing it at 30% fan, which already is quite a lot of air down here. So maybe let's just run like another pit after that with 60% fan and see if that helps. Yeah, but otherwise we can do that, and then we just set the max hour to something extremely high for now. Just let the pit auto tune run and then remove the section again. That's an interesting error to have, like that you cannot even calibrate the pit. Now it's crazy, like you see how it's heating up, and then as soon as like the heater turns off, it just drops basically at the same rate as it's heating up at 60% fan. I really hope that we just pop in the fan and it just works, but for some reason, like whenever I do something, it's never as easy as that. So, too bad. Here we go. Okay, we have a pit. Let's quickly do save config. Extruder option control configs with included value. What does it do now? What did it do now? Extruder option control. So these are the pit values. Control pit. What is not a problem? I think it doesn't like that my extruder is not configured in the main file. Let's remove that from here. Let's just grab the pit values here and let's just manually put them here. So I just need to replace equal sign with the colon. And then we can remove this, this, and this. Space here, save. Section extruder. Just said, like, why can't anything be easy? Yep. Can I do it? Okay. You've already provided an answer, but yet your printer config consists of only includes. Clipper is only able to update sections in printer config and nowhere else. So each config section that may contain a savable item must be in printer config. Yeah, okay, so basically what I do is not what they want me to do. But nevertheless, I still would like to just like reset that now. I mean, I have the values, I can quickly put them myself. Let's just restart. Okay, let's just put it manually. Okay, lesson learned. Clipper doesn't like this. Steps. These are the correct values. Then I think they are now applied. So let's set the fan to the 60% we had. And do it again. Heater is heating. Basically, goal is to not fail. Okay, maybe Yeah, I mean, yeah, we have to wait. Not much else to do. See, we're almost at temperature. Let's just see if it like craps out in the first cycle again. But it's still at like, it heats at 100% still. And you see like how slow it gets with heating. Oh, crazy. Now you also see the difference here, right? So you see like how it's going up and down here with the changes. This is 30% fan, and now you see here like how much slower it heats up again on 60% fan. I mean, it does heat up now. But yeah, but that's the difference, right? 30% and 60%, they take twice the amount of time to heat up. Now I'm curious to see like if we at, because afterwards like we need to do 100%, right? If we then still get like not heating at the expected rate. Okay. Wow. Then we need to configure the verify heater. I don't think there's a way around that. Yeah. So we need to do verify heater for extruder. So I think the heating gain we can just lower from 2 to 1. So basically we just allow it to heat slower. That's my understanding of this, right? Because at the minimum temperature that the heater must increase by during the check gain check. Yeah, and it's also increase the check gain time to 30. So it says the default is 20. Speak of the Wago system, right? They have the 40 and the 60 heater core. I think I now found a use case for 60 here, 60 heater core, the 60 watt heater core. Let's quickly put this up to temperature before we turn on the fan so it heats quicker. And I did not expect that I have to like battle the fan in this way. I'm just moving this over. it's a bit more comfy for me to sit here on the laptop because immediately now we are doing like configuration stuff. Okay. Fan 60%. Look at this drop. Just like from turning on the fan. It's like I expect the world best overhangs after that. That's a question, right? Because we are at 66% fan now. And it can barely heat up. So the question is, can it even hold temperature at the 100% fan? Okay. It's ridiculous that we can't even get through the pit auto tune. Let me just put it back to temperature. We don't have to wait for it to heat up again. Just in what hotend has it, and does it have a silicone sock? It does have a silicone sock. So I think the problem, the hotend itself is the MicroSiwss all metal hotend, which was like a very popular upgrade for the Ender back in the days. So basically the heater core is still the original Creality from the Ender 3, which I assume is like a 40-watt cartridge. It does have a silicone sock. I mean, I can also show you, right? The fan is a bit overkill. That's the problem. The fan is really powerful. So you see the sock here. So basically the fan just cools the hotend too much, which is an interesting problem to have. And we're only using 66% of the fan power. Okay, let's do the following. Let's just set max. I just wanted to complete the pit auto tune for now. So let's just set the max error of the verify heater section to like a ridiculously high value, which I would not recommend for continuous use, but for now, like we're sitting here, we're observing. Let's just set this to, I don't know, something like this. And the check-in time, let's just also increase this. And heating gain, let's double check that I understood the parameter correctly. So the minimum temperature that the heater must increase by during the check-in time. It is rare to customize this value. The default is 2. Yeah, so I already halved it to 1, so this should be fine. hysteresis? Not sure. Let's just leave it at 5 for now. So basically we just up the max error a lot. Let's try this and then let's see if we now can get like a successful pit tuning at 60%. Oh, forgot to set the fan. Ah, okay. Now I have to emergency stop it because it can't cancel the pit tune. What happens at temperature and 100% fan? That's an interesting question. So basically during the print, it just shut down because like heater didn't heat at expected rate. But let's actually quickly do the sanity check. I think that's good. Can we actually keep the temperature? Otherwise, like we have to like cap the fan at some value. So let's just put it to 215. And then let's quickly wait. But here you see here, Wes, this is like at 30% fan. Like this is the pit tune we did. And then you see here, this was at 66%. So you can see how long it took to heat up already at 66%. So it's really like a very stark difference from here to there. Yeah, and then basically there where it spiked, the fan turned off and it just spiked up. Let's see. Okay, we're now at temperature. Now we put it on. Now we will most likely see it drop. Yeah, we just dropped. Look at this. So we just dropped like 25 degrees. The fan is fine, like the fan shroud is fine. Now turn it off and like you can see it most likely like shoot up. Yeah, see here, like it's immediately shooting up. Yeah, it's a thing, like it should not. I mean, like it's a standard like part, right? Like the stealth burner has like defined height of the nozzle to the bed. Like this should be like okay. I mean, like the airflow will hit the heater block. I'm sure I can show that, but like I mean, I can just move it up, right? I can look a bit from the bottom. That's the camera. Let's. Where am I? Here am I. So. It hits pretty much directly on the heater block on the edge. So you could be right that this might be like problem. Like here without the sock you see it a bit clearer, right? So it's a bit dark. Really sorry. We'll focus on that. Yeah, here we go. So it definitely hits the edge of the heater block here. But I don't think that like the hotend is incorrectly positioned. Just a bit of a ridiculous problem to have, to be honest. But it's also like the problem is like it's not really usable in prints, right? So that means like in prints you need to very slowly ramp up the fan speed. Like if you put it from 0 to 100, it's like it will kill the print, right? Like if you have a hotend temperature, it suddenly drops like 25 degrees. I would say let's run like another Pit auto tune. I mean, now the like we saw, it can keep temperature. Let's just run a pit auto tune. %. Seems like the hot end is too high or vice versa. Does the fan only blow on left hand side? And it's both sides. Both sides. Let's see. Well, this is most likely my audio is also not good because the fan is, it's not super loud to be honest, but the voice suppression. Not at the back. No, not at the back. Only left and right. Maybe rotate the hot ends so the cartridge and thermistor are shielded. I don't think I can do that. No, there's no space. To be honest, if it doesn't work, we cap it at we find a fan value where it works, maybe 50%, and I just accept that the fan is much more capable than what the printer can deliver at the moment. I'm planning to replace the hot end anyways, soon-ish, like not super soon, because I'm kind of running out of money for spending on like weird stuff I don't really need on my printers, but I wanted to put a Wago in there. And then I think like this would be like a good use case for a 60-watt heater core of the Wago. Because like having so much cooling is an interesting thing, right? Like overhangs should be really good. Might be just overkill for now at the moment, but now it seems kind of okay, to be honest. I mean, heat's slow, but let's quickly already jump to the slicer and work on our slicer profiles. Let's quickly see. Okay, so those we don't really need. I'm not quite sure. Is that a filament setting? Cooling. I'm looking for a setting where it's like start fan at layer X and then like ramp up. Wonder why this is 0%. At the top of cooling? Oh. Thank you. Yeah, but this is the problem here because we have no for the first, and then layer 3 has already 100%, so we have like really large steps. Let's just do this at layer 12, 10. Let's just do 10. But I don't want to modify my material setting for that, right? because like I use material on different printers. Yeah, the max fan speed, I would change in the printer config, to be honest. Because I don't want to modify my material settings. Because yeah, it should work for all my printers. So what we can do is we can, in the printer fan here, there's a max power, which we can set to 0.66, for example. So 100% is 100% in the slicer is 66% in reality. Okay, we successfully fit autotune. Let's quickly move the values. And let's try print. So we'll still go to 100% fan. Let's just observe how that is behaving. Let's see how that goes. But yeah, like this is not really like a ideal configuration with the verify heater here. Because basically now it's, I mean, it just didn't cancel because of this extreme max error, right? So basically we just disabled the heater verification. So we need to find a value that works there. I mean, this looks kind of okay, to be honest. Like, looks usable. So my goal would now be, let's just try print. I first want to like know that like what we're doing here makes any sense. And then I would try to run another, like reduce the, or like put the verify heater settings back to like sensible values and see if we can still get a bit autotune to complete. I thought about adding like a external cooling fan to this machine, because there's like a lot of space like on the back here. There's nothing here, and like you can mount like some fan here. But to be honest, I think it's not needed. This is a pretty cool fan. I mean, the one that we had before, like this one, like it was so weak that the overhangs were like horrible, like horrible. This is the exact opposite. But yeah, like so basically the I'm even not sure why I just took like the most cooling performance one, like knowing that was a bit too much. Like this one has extremely high speed, and it's kind of meant for enclosed spaces, kind of like have sufficient cooling in like high temperature environments. So yeah, for open it's a bit overkill, but yeah, I can just limit the power, right? But ideally, like, you know, like if the performance is there, I'll try to make use of it first. So now basically we phase in the fan over 10 layers. Hopefully this prevents like any massive like drops in the temperature. Okay, should start any second. Then let's keep an eye on the temperature graph. I'll make it big here on the sides. So interesting. It's also like we print with 225 now, like pit tuned for 215. Let's see. Did you print a modified shroud for the MicroSiwss, or is it a standard stealth burner? It's a standard stealth burner, but is there a modified shroud for the MicroSiwss? I wasn't aware there's such a thing, because like usually it's just the mount changes, not the shroud. Just looking at that. Thingy words 5178. Let me check it in a second. Yeah, we dropped 4 degrees. It's fighting hard to save up to 220. We are now at 100% fan. Yeah, just... Okay, this is not feasible. Like, look at it. Like, it's just like 100% heating. And it just keeps dropping the temperature. Like, it just cannot hold the temperature. Basically, if we wouldn't have like disabled the verify heater, it would just be gone at this point, of course. The interesting part is that like we tried it out in the beginning and it could hold the temperature. So seemingly now, because I assume because we push filament through it, the filament also takes out energy of the hot end. So now we are arriving at the maximum temperature at some point that the hot end can sustain with the fan on. Yeah, it just keeps dropping. For materials, okay, it's PLA, so it should be able to print at like 190-ish. Let's just finish our little test print. $206 and dropping. $205. Yeah, there's still swinging going on and stuff, but it's a different topic. Yeah. There are still some issues we have to fix. Like print-wise. But the overhangs look much better. Like it's not consistent with the extrusion for some reason. I still need to figure it out. But at least we now have overhangs. Before, like, we basically had 0 overhang potential. Yes, I changed the retraction settings, Steve. So basically I first tried the 0.4 that other people use with Stealth Burner, and it didn't work. Like my suspicion is still that the hot end or the nozzle has some issues with the stringing. Yeah, so basically there's just like a lot of stringing here, but it's also like, I mean, now it's like just like, you know, like the temperature was dropping the entire print, so it's like not really like a good sample print. But you see like here, I have these weird issues with like this like missing extrusions a little bit. Okay, so to be honest, I think what we can do for now is we can just limit the fan power to like, let's say 50%. Which should give plenty of cooling. Let me just quickly do that. And then we quickly check the thing, but I'm pretty sure that this is exactly what I used with, like, without looking at it. I got mine from Thingiverse. Yeah, so this is the part you need to mount it. Oh, sorry. Yeah, this is the part you need to mount it here. And this is like customized for the tool head, right? Is this the part you need to customize? Wait, I also linked it in my YouTube thingy. I think. This is very meta. Stealth Burner MicroSiwss. This one. Yeah, this also has this front part here. I'm fairly certain that that's what I used. Yeah, see, like this even branded MicroSiwss. So this is definitely what I used, and this has the vents here. So this should be fine. Yeah, I mean, like, I can pull it apart, but I guarantee you that it says MicroSiwss on top, because this, see here, this is the shape of the hot end. And here are the heatset inserts where the hot end is mounted. I guarantee you this is the part I use. You're so different than mine? The sock is different for sure. I don't think this looks different, to be honest. Like, if I kind of replicate the angle a bit. What do you mean by too high? Like the hot end isn't high enough, or? I don't think I can modify that, right? Let's quickly shut it off and let's do some hardware diving. In the image, yeah, that's true, but let's see. Let's just take it apart. Let's take a look. But I don't think I can like adjust the height of the hotend, to be honest. Oh, no. Okay. We have to pull out the filament first. Otherwise, this will be like absolute pain to like take apart. I have a hunch. I think you can loosen the heater block, and because like it's connected with like a single screw, potentially mine like slipped down over time. I never adjusted that. I have the feeling this could be the cause. Let's quickly pull out the filament. And then let's just take everything apart and just look at the hotend. I don't think we will get to the BLTouch meter today. I mean, we're now like on the fence. It's like 3 hours. Wes, you missed the entire fun. Like we soldered on the toolhead board to bypass the component. We had a lot of debugging fun with that. It's fun. Oh, interesting. Oha. Okay, I can already tell you like one thing maybe why I have printing problems. That's something. I think this should be maybe fixed in place. But I checked the nozzle. That's like 2 weeks ago. It was kind of okay. Didn't see that. Okay. Okay. What's new watching your streams? Nothing is straightforward. No, I to be honest, I'm not sure if it's me or if it's just like something else. So it must be me, right? To be honest, like I make more mistakes during the streams than if I just worked on my own. So that's one thing, because I'm just like more distracted. And it's also like managing the camera, paying attention to everything's in view, like it takes some mental capacity. But yeah, like I also feel like things don't work out all the time as I want them to work out. I guess it's best to remove the connectors on the side as well. Just like take off the whole thing, then we can like look at it and like. So, you just need to be very careful with the thermistor. Maybe it's a good thing, like when we pulled out, maybe we can just extend the thermistor wire by like 1 centimeter as well. So this is one cable, because the thermistor was like really painful. Oh, I remember. I didn't print the customized part for that. Let's just loosen the board a bit, so we can like shift it around a tiny bit. I remember. Oh, well, okay, that also works. I'm not quite sure why this now came off with the entire thing, but Okay. I guess off is off. Okay. Let's take a look at this bad boy. The first thing I can confirm, it's the MicroSiwss one, the one we saw on printables. But I can also confirm it's definitely like lower. And I think the problem you see here, there's this gap in the heat break. And I think this might explain a lot of problems I have. I mean, firstly, it's loose for whatever reason. Which definitely wasn't the case before. But the loose hotend will explain like a lot of problems. Especially here with like the layer consistency and stuff, like this very much looks like loose hotend. Well, like I was playing around on the novel like I don't know, like 2 weeks around, and I like did not find it to be loose. Okay, but like so the MicroSiwss has like the single screw here. Yeah, it's still hot. I can confirm it's still hot. And this screw kind of like holds it together, if I remember correctly. And then it has 2 screws here to hold the heater core. Oh no, the gap is intentional. The gap is intentional. So I don't think I can move this further up, to be honest. Let's just remove the graph screw here. And this should come out, if I remember correctly. Maybe we should disassemble that when it's heated up, to be honest. But it's definitely like from the position, there's nothing I can modify. This is how the part is. Because you also see like in here, there's little like slide thingy basically where the grub screw goes in. So this is the height the hotend has. Potentially here on the bottom we can move it up by this much, but like not by a ton. Now looking at the printables, I know at stage right you make mistakes when you watched. Yeah, that is true. You don't really see it here. Let's quickly just look for a reference image of the MicroSiwss hotend. It used to be nice and shiny. Can I just maybe have this open somewhere? Amazon? Yeah. Let me know. Just show me the picture. Yeah, you see here, it has like a little bit of the thing here, then the gap, and then this. Which is exactly what I have too. So the position is correct. The position is correct. It can't go any higher. And looking at this, yeah, it's the same part. Like the spacing here looks It looks identical. Okay, and there's also no point in like removing the nozzle section. I could replace the nozzle at some point. Need to check if I still have some around. But that's beside the point. So I think that the position is correct. Use the image, so look where the ducts point. Yeah, but it's the same part, it's the same hot end, so I don't see like how they could point in different positions. Put it back together. I mean, we already found that the hot end was loose, which is a good one. Potentially, we shouldn't need like thread locker there. You tell me to look at the image as reference. So let's recreate the image, right? More like this. For me, it looks identical. You think? Where's the sock? Where did I put the sock? Oh, here. I don't think. I mean, it hits on the edge, but it's the same part, so. And it also was never a problem, right? Like with the two fans before, I never had this problem. So I think it's just now that the fan just blows too much air in this general area, causing that issue. The image misses the heat block. I don't know, like, to be honest, like for me, this looks pretty much the same. Like, this is where the duct blows. So, for me, this looks fine. I don't think that's the issue. So this all kind of like goes in the nozzle direction. What I find curious is like I have a Mark 8 sock and the guy has a Mark 9 sock. And my sock doesn't like 100% fit, I think, which... See here, like there's like, it doesn't 100% fit. Potentially this might be part of the mystery. And what's also noteworthy, I would say, is that like the thermistor here is quite open, right? So the thermistor is directly here. And we do blow air more or less directly on the thermistor. So the question is also like if the heater block cools down as much or whether we just cool down the thermistor that's there. I don't think we can do anything here. Let's quickly let me grab my curious box of mysteries and see if we have a different sock laying around. I'm also not sure if we can switch the hot end direction. I think Wes, you suggested it before as well, right? if we can like turn this around. I mean, to be honest, the reason I put it in here like this most likely is because like the cables come out this side. And well, the answer is yes, we can turn it technically. Now the cables are on the wrong side, and the heater cartridge, like the thermistor, doesn't have an opening here, so it must be on this side, which means it needs to go in this direction. That's the only way to put it in here. But to be honest, let's add a strip of thread locker. Tiny bit. Just need to be a bit careful with the ABS, so let's not make a mess. Because ABS doesn't like thread locker. Okay. Hopefully this prevents the hot end from coming loose again. Okay, perfect. Cool. Yeah, but let me quickly check if we have a different sock. And otherwise I will just put it back together and limit the fan speed. I think that's the best thing to do. Give me 1 second. I think Wes means to rotate only the heater by 90 degrees in the heat. What do you mean the heater 90 degrees? You mean like the block here? Some team in the European Championship just scored the goal. I guess it's the Netherlands. Oh, loosening the grab screw. Like, you mean this one here in the center? We need to heat it up first to get any movement there. But also then, like, the cables need to come out the side, right? Otherwise we can't really route the cables. Let's really see. Like all my old ender parts are in this jar. And I don't see a sock in there. So potentially something I need to order. No sock in here too. Okay, and I have to order like a better sock. Put the cables at the back so the fan shot doesn't block. Yeah, but it's also like not centered, right? So the opening of the heatsink, like this is not centered. So if I rotate that, this will be blocking the vent directly. And I don't think this works rotated. See here? Like if I rotate this, it rotates around the nozzle, right? So if I rotate at 90 degrees, this will basically directly be on the block. So this doesn't really work rotated. If we rotate it 180 degrees, you know, like that this part is here, potentially this might work, but then the cables come out the other side, which is not really helpful. And then it's also like we're then really close at the BLTouch. So even if we manage then the cables to route like around 180 degrees around the heatsink, we can try it. But to be honest, like, I'm really planning on replacing this heat like this hot end, so I'm not really eager to like do some hacks. Yeah, it looks close. Yeah, definitely. I mean, 180 degree, yes, but then we need to extend both cables now because both will be too short. And it's also like very, like then we are like right at the edge, which means basically the heater block will touch the BLTouch. So that might also not be. Also not ideal. Okay, let's put together. At the very least, we found that the hot end was loose, which should help a lot with printing quality. So now we have to fiddle this back in. Yeah, the sock doesn't fit 100%. So this might also be part of the issue for sure. And what we can do is we can try to wrap the heater block a bit with the golden tape. Just going back to the printables image, isn't your hot end different? It shouldn't be. How would it be different? It is different. It is different. But it says MicroSiwss and Mark 8 hot ends, and they should be compatible. West, you're like a detective. I mean, it might be short, right? Because this doesn't really impact the compatibility, generally speaking. Yeah, it's a different hot end in the picture. And it's definitely a bit shorter. Yeah, you're right. Okay. West, I concede this point to you. If you compare it here, look at the bottom. Oh, sorry. Look at the bottom block. The transition is directly here in this like curved section, right? Now look at the picture on printable. So my curved section is down here. So it's like 2-3 millimeters longer. Interesting. I don't know, like, does the dude have an older version of that or something? Because, like, I mean, like, if I look at this here on Amazon, right? This is mine. This is mine. You see there's no studs left and right, and this guy has left and right the studs. If you're planning on changing, maybe glue some small plastic strips on the top of the ducts. to direct the air away from the heater block later on. Yeah, which is why I was saying the ducts look lower. Yeah, like Wes, you're like correct. Like me, the ducts, I couldn't really like determine it from the ducts. We can. The thing is just like if I start gluing plastic there, I think it's like too close to the hot like to the thing. And I didn't plan on upgrading the hotend like in the next 2 weeks, right? I mean, we can reprint those parts, right? Like we can modify them in Fusion. There's a bit space here. So technically we can just move everything up by 2-3 millimeters. Basically until it just touches the inset here, right? So you can move it up to basically this line. This is how much space we have. I almost got a 60-watt Wago the other day. There was a deal on Jake 3D, but I missed actually sending the order by LD. Oh, that sounds horrible. But yeah, they had like a lot of like deals also on 12-volt Revos, where I'm like questioning myself why there are 12-volt Revos, but you got them for like 60 euros as a whole starter set. Okay, then. Yeah, I mean, we can reprint both those parts, modify them, and this should fix the issue in a certain way, I guess. Guess I saved quite some money. Well, you need the filament eventually, right? So, okay. But then I guess the question is that one of two scenarios will happen now. Scenario 1, I will order a Wago hotend tomorrow. Scenario 2 is I modify and reprint the parts. Let's quickly check if somebody did that already. There's also make some comments. Summer build. See, this guy uses the same hotend. That's the same. Same as me. No stats left and right. Oh. So he has the same problem. He's like directly like blowing at the hotend. Oh, see, do you know like this shitty fan? I can tell you this fan will not cause the issue that I'm having because it's just too weak, like by a long shot. I also wonder why he glued it in. But yeah, that's beside the point. Yeah. No remixes, so okay. But there's a step file, so we can modify that in Fusion, no problem. So that will be then my task for tomorrow. Or I order the Revo. Let me check my account. I'm making a decision. I should get salary like on Monday, so that's why I say to myself too. Yeah, I really don't have a lot of filament, to be honest. Like I have like 12 spools, and I'm really like I try to use a filament before I buy new ones, so I try to not keep like rolls with like 100 grams. I'm quite good with that, I guess. I want to try this new Swiss hotend that's about to come out soon. What new Swiss hotend that's about to come out soon? Can you send me a link? Not that I like buy now a Wago and I regret the purchase. That would be horrible. Oh, wait, no, where's the... So, yeah, then you can order some more. Like 12 is not a lot. So Octo has the filament manager support, right? And I didn't think people had like too much filament. So the list is not super optimized for like the filament list from the filament manager is not super optimized for like a million entries. So I basically just put a hard cap at 100 spools. That was like, it only showed the first 100 spools. Worked well for like a couple months. And then somebody showed up in my support ticket saying like some of his spools don't show up. After a little bit of investigation, turned out he had like way more than 100 spools. So 12 is okay. 12 is okay. Yeah, there's for Clipper there's Spoolman, and for Octoprint there is Spoolman, Spool Manager, and Filament Manager. I actually have a test, and here this is my testing. Oh, I mean there's not much in here. It's just like for testing for me. So I have like three spools here, and I don't really use it. But it's really easy to set up. Like I run it in a Docker container, which is like super simple. And then yeah, it's a bit stiff with configuration. Like you need to set up your vendors, and then you set up your filaments, and then you have spools of those filaments. And then you just have like all the different like data about those spools. And that's pretty much it. And then basically like what you do in mains, or like in Clipper, or like in Moonraker to be precise. In the Moonraker conf, you just basically add like a spool man section here and just point it to wherever your spool man is running. And then basically when you start a print, it will just ask you like, hey, which spool is that? So it's actually quite cool, and it just counts down how much material you use from the spool, how much is left and stuff. Discord. Would be cool if they would integrate it with Orca Slicer too. Yeah, it would be cool, like if you can just like select the spools from Spoolman in Orca Slicer. Oh yeah, I saw this one. I saw that. Somewhere I saw that. But it's compatible with the Revo, right? So it's just the hot side basically. But to be honest, what I noticed, like, I have no different nozzles for the Revo system, and I barely switch. So I'm not quite sure if like a quick changing system for nozzles is really something that I would be really eager to spend money on, to be honest. It's like the lesson I learned is like, I can switch relatively quickly now, and I don't really do it. So yeah, maybe not worth the money for me. But it looks really cool. Like it's just like cool how it splits open and you just put the nozzle in. Okay, let's try to fiddle this back in. Oh. Okay, well, that's not quite how the plug is supposed to work, but it works. And that's back. Let's plug this back in as well. I need to see what I'm doing. much easier to actually see something. Okay, so this is back, the thermistor is back. Let's close it up. The nozzles seem much simpler than Rabo. Yeah, that's true. That's also like one of my gripes with Rabo actually is because like the nozzles have that super long like I mean, I'm not quite sure how those look. I didn't see it now. Yeah, they're quite short like compared to Rabo. Like you see like here they have like only this section. The Rabo nozzles are much longer. And it basically what happened multiple times for me is like that I had a clog in the upper part basically of the cold side of the nozzle. Basically when you like pull out filament in bad timing, basically what happens is that the filament cools in the above the nozzle and just gets stuck. And this is like a really stupid clog because like you cannot heat it enough to like melt the filament again. So what I ended up doing is like I flipped the nozzle over on its top, like had it like sitting in my oven and heat the oven to like 200 degrees to let the filament like run out. It's stuff like that. It's super annoying. That happened like multiple times for me with the Rabo nozzle. I was really frustrated at some point. So that's like the one thing I really don't like about them. Besides that, they work great. Let me be sure I did that correctly. Okay, then for now, limiting the printer power it is. The fan power it is. And then I just think what to do. I also want to start printing parts for my printer design thingy. Like, not sure, like, lots of people who are watching. I didn't work on that for quite some time. Like, I started to design my own printer earlier this year. I was a bit frustrated with the project and I let it sit for a couple of weeks, months now. I think I didn't work on it for like two months or something. But I started working on this again and I make progress. So we have work, I mean, on paper, working that. I designed the skirts. I did some YouTube posts about that. And I'm kind of ready to print the parts for like the bottom section of the printer. And it's something I want to do now, like over the weekend and next week, so that we can like next week. My first point of order would be like to rebuild the top section of the printer, because a couple of parts there changed, and I also now have better belts. So that would be like next week most likely than the thing. But yeah, for here, let's quickly try again. Let's just limit the power of the fan to 50%, so it's not cooling our hotend too much. Devices. Did I already do that now? Fan max power 0.5. Okay, so we are at half power now. The pit tune should be somewhat okay because fan was at 60% there. So let's just print our cube again and see now. Does it now look better with the hotend being properly in place? Maybe we can also insert filament. That would be tremendously helpful. Also basically a thin tube that gets pressed in a certain way so they can they increase the surface area and achieve some similar effect to CHG. Oh yeah, that's I remember that. Yeah, I'm not quite sure like where I saw them. Like was on some like printer conference, and people making videos about it. Okay. But yeah, like I'm still having the stringing issues on this machine. It's kind of like a consistent theme since a long time that I always have stringing issues on this machine. It's the third extruder now I use with this hotend, and I still have stringing issues. So I also have a bit of the suspicion that the hotend caused the stringing issues. So yeah, maybe it's just time to like kick out the hot end and just like replace it. Do you have some LEO version of that fan? You mean the part cooling fan? I don't have a 5015 LEO fan. Do you know what they ship with their kits? I don't know, like LEO Trident bomb. The LEO fans are most likely good. Like they have high quality parts. Like I'm super happy with the V0. So I'm just pulling up like some random Trident Vision C. Let's just see 50 fan. No, it's not specified. It just says fan. I'm not quite sure what they have. But basically the one I have now is the Honey Badger 5015, and then there are different versions, and I have the... It's complete overkill for this machine because it's open air. This is the one I have. So basically there's a 6400 version. 6400, there's a 7000 behind the images here, and I have the 9200 open beta. It's complete overkill. Yeah, it's complete overkill. It's really meant for like enclosed printers. I assume, I think like most specs I've seen, because I looked now at different fans, like most specs were in this range, like RPM wise. And because the design of those fans, they look basically identical to me. Maybe there's some like microscopic difference, I don't know. So I would assume like whatever LDO delivers is in this range here. I was thinking of moving to Dragon Burner, but maybe just a bit better fan could be enough. But Dragon Burner uses the small fans, right? Yeah, exactly. Like here you have the smaller fans. Like two of those, I don't know. Like I'm not super happy with the cooling on the V0, to be honest. Yeah, but I still like the two are not saving you, I think. I mean, potentially it's also like a high performance whatever version. But like the fans from my LDO kit on the V0, it's okay. But if you print high-speed PLA, like the fans are not enough for sure. I was actually considering adding like an external fan on the side to improve cooling there. Dragon Burner should perform much better than the V0 standard OLED. Maybe? I don't know. Like maybe the cooling ducts do some magic. But they look very similar to what the V0 has. There was a video by Modbot switching to that on his V0. Okay, I'll check it out. I'll check it out. Not claiming that I'm like completely up to date here. Let's see, it looks a bit weird. Oh yeah, the Z offset is completely completely baked. Okay, let's just see what happens. No, by the way, Jonas, this is also new in the beta. You now get the snapshot of the printer basically with the notifications. Okay, let's see. So the fan basically ramps to like 100%, but we set a like basically now it's like 100%, but it's only 50% of the actual max. And we are keeping the temperature, so we're still at 224. It dipped a bit, but I think that's like in range of what's acceptable, and it kind of creeps up again. So 50% fan speed seems to be okay. I get a third layer notification before the first layer on my machine. Yeah, it's a common issue. The problem is basically that the layers are detected from the Z height. You also see it in mainsail and fluid. So basically here, this layer. Let me just show you. So if I pause now, you see what happens here? I mean, now you don't see it, but now it's like layer 39 of 39. And the reason is because the tool head moved up. So because the tool head moved up, it's above layer 39, so now it's layer 39. That's a problem I have to tackle. So basically the solution for that is to download the G-code files at the beginning of the print and then parse the G-code file. But just from the tool head position, you cannot determine the layer. Most likely your prime macro. So if you have it for like, let's say like 1 or 2 millimeters above the bed, after, I need to check the rules exactly, but yeah, I just gave up optimizing that because it's just like you cannot make it perfect for everyone. Hi there, Big City Tours. Yeah, I think the 50% fan speed for now is fine. But the stringing is even worse now than it was before. Yeah, I just have to sit down with this machine for like half a day and like tune it and figure out what's wrong, because like, yeah, there's definitely something is not okay. Man, this looks worse than the first one. This looks worse than the first one. So this is the one we just printed, and this is the first one. We just printed this for the first one. Maybe we should like loosen the hot end again. It looked better before. Okay, yeah, the initial layer is completely off now, just because like we disassembled and reassembled the hot end, so that's kind of to be expected. Then we have like this one line here, which just comes from the pause we did. Like this didn't quite resume well. But overall, I think at least we now have cooling. Like these look better than the ones before, because like with this fan here, like it was just impossible to get like any overhangs. So we are now getting there. Yeah, so I would use this as a cutoff point for today. Let's just say this took way longer than I expected to just install a different fan. I mean, we had to do some soldering on the tool head board again, removing like another. I saw it somewhere here. This beauty was defective. So we removed this from the tool head board. Logic level shifter. No more logic level shifted, but it still works. So the fan is working with PWM. We did not get the tachometer to work, like the speed signal, but I don't need that, so I didn't spend time on that now. The fan is way too strong, and the tool head is not positioned correctly. So we found out some things that we need to improve. Yeah, so for me, like as I mentioned, like let me just check tomorrow. I either make the decision to get rid of the hot end, because I still have the suspicion that the stringing partially comes from the hot end at least. So having like a Wago system would like remove that weird hot end with the Ender leftovers, and then I think we are like on a clean system. One option, the other option is I reprint basically the part of the south burner that holds the hot end and just modify it to like move it up as much as possible. But then the problem with that is like we're kind of like getting like in a string of problems there, because then the next part will be, I mean, focus is not a thing today, but if I now move the nozzle up, you see like the red like little thingy is the BLTouch, right? It's barely above the ground again. So if we do that, I also have to reprint the base to move the BLTouch up, because then the BLTouch is like too close, and I have to reprint the entire base. So this kind of like escalates quickly. Potentially, the Wago most likely will also sit higher up. I think the nozzle is just too low at the moment in general for a self burner. So yeah, that definitely means we also have to reprint this part. At which point, I'm just like wondering, because I also want to replace the BLTouch at some point. I want to swap in the BTT eddy. I want to swap in the BTT eddy as soon as this is available as CAN version. So as soon as this is available, that's a good price. I take 2. I hope they rework their pricing strategy. Just redesign the duct position rather than shift the hot end, just reposition the duct. Yeah, but like if I reposition the ducts, right, I also have to like redesign the entire front plate, because like this needs to fit here, right? So moving the hot end up is much easier. It's like a 5-second thing to just move the faces in Fusion like 2 millimeters. But then again, like I also have to redesign then the part on the back, because the BLTouch mount is from here. BLTouch here. So this part I then also need to modify, right? Because the BLTouch is too low. At the moment, like it's like, let's say like 0.5 millimeter above the hot end, which is already quite not so good. But then if I move up the hot end like 2 millimeters, I also have to redesign that. And then yeah. But if I move the ducts, I have to redesign the front. And to be honest, if I have the choice between redesigning this one and the front, I take this one like every day of the week. But then the other thing is like, if let's say like Big Tree Tech in 2 months have this available as as canvas version, I want to swap this in. But then basically like the work I did is kind of pointless, because with this I don't need to redesign anything. So potentially I just postpone like we leave it now as is. Like I accept the flaws that like we have. I mean the cooling is okay, right? So I accept this just as is for now. And as soon as this becomes available, I buy the Wago and I buy the eddy coil. The eddy can. And then we put both in at the same time, because then we have standard parts. We don't need to rely on any hacky printables files that somebody did like 5 years ago. We just use the standard parts, because this fits in the standard switch wire toolhead mount here. And then we also have like a standard Rabo mount on front. So I think that's the best. I could try the flex tab. What is it? I know tab, but what is flex tab? Yeah, but the problem is that is not compatible with the switch wire. That is not compatible with the switch wire, right? Because the problem with this, I mean, arguably, I think it should work, but the problem why it's sad that tab is not compatible with switch wire is that the bed is not stiff enough. So basically, like, you will not get precise readings because the bed is basically only mounted in the center, right? So basically, if you press down on the edges, like it moves too much. Whereas if you compare it with like a trident, where the bed is mounted on the corners and the center and the back, or the 2.4 where it's like completely like fixed, this is not stiff enough. So tab is out, and then I think also flex tab is out, to be honest. Yeah, that's also why I don't recommend for V0. Plus, there's not really like a lot of space to add anything on the V0. But yeah, that's the reason, because like it's just like not stiff enough. So for here, like the BLTouch is fine, because BLTouch doesn't exert enough force to like modify the or like change the bed. But for me, this looks fine. Like the eddy sensors, they have like one requirement, which is you need the magnet needs to be like a magnet back plate, basically. Like like for example, the Prusa printers have like embedded magnets. That doesn't work. I think that messes up the fields, the eddy fields. But I run steel plate anyways. I have a normal magnet, so the eddy sensors are fine. And like if the can version is somewhere in the price range of that, right? Like if it's like €25 part, that's a really good deal, and it's just super fast. So I'm happy about speed. You don't have the automatic set offset calibration that you have with tab, so that's one downside. But yeah, you see here, like it just fits in the normal part here. It's completely compatible. So just like rambling about that, I think like what I will do is like we keep it as is now, and then in 2-3 months, when this is already or available, we just swap in the eddy can and the Rabo hot end. So for now, basically, I would just like, let's see if I do it tomorrow, but I would just spend like half a day on the machine, just like printing, trying to figure out why we still have like problems. Potentially, I would just rebuild the extruder a bit, because it looks a bit like extrusion issues. Now that like before the cooling was so horrible, that was drooping down. But I think now extruder would be my next guess. So yeah, just trial and error, try and figure it out. You could also do clicky. Yeah, I can do clicky, but I don't know. Like I kind of want to wrap this up slowly, because I'm working on this now already. I mean, would need to check for like 6 weeks or something at least. And this was more like meant as a small like intermediary project. So I kind of want to wrap this up. I also need to get this back up in printing, because I have a couple of things that need like a little bit larger bed to print, because this is my largest printer, sadly enough. So this needs to be up and running again. So for now, I think I'll just keep it as is, try to fix the issues I have, and then see where to go from there. So next week, let's see, potentially we do like one more stream on this, depending what I find or how it goes. And then the week after, I think I would rebuild the. Let me show that. I mean, this is where we left off, right? With this machine. Yeah, I'm kind of running out of space here. It's not really like a two printer compatible space here. So this is where we left off with this machine. So we kind of did some messing around with that, but yeah, that's over. So basically, the part in front here changed left, right. So we need to replace this part, and also this part here, like this like motor bay changed. It basically now has like a little arm coming out to have a belt here, and then also a belt in front. So we have 4 belts holding the bed, and then the bed runs on the bearings on the front rods here. So basically what was ready already is those parts. I'm pretty confident they are final. And then on the bottom we basically have the 4 corners. So we can also build the bottom part. But I think next week I would like to first rebuild this. Because we use these shitty cheap belts here still. Like initially this was meant to be like a super cheap printer, and I wanted to have below 100 euros, and yeah. Turns out the cheaper you build something, the more complicated it gets. So throwing money at problems is a very good solution sometimes. This is why for now, like this is like a no budget printer basically. I just build it and see what works, and then like later maybe we can optimize. But basically, yeah, where was it? Yeah, the belt. So we will redo just like the entire belt thing here, replace a couple parts, which means we kind of have to take apart quite a bit because it's kind of like a central part holding everything together. And then the week after, we most likely build the bottom section. And then we need to see, like, I didn't design the actual like bed yet, but I assume it shouldn't be too hard. Fingers crossed. Because basically all it needs to do is like grip the 4 belts and hold the bed. And should be relatively stiff, but I think it's fine because we now have it on all 4 corners. Like it will be lifted the same on all corners, so it doesn't need to be like super stiff in any direction, because like it will be lifted up gently on all sides. Arguably, I think it should be even quite loose, because then what you can do is you can just ram it on the bottom to like level it out a bit. If it's like too stiff, that doesn't work most likely too well. But yeah, that's this machine. So we will start working on it again. And yes, it's not running super well here. Like here's like one spot where it kind of like wants to like fall into like a valley. Yeah, so next week we just rebuilt this. I hope that the belts are part of the problem. That's also why I want to have the belt meter, that we can like ensure the belts are kind of similar tension and just check like what tension should be, whatever. And then like we also can use the main board we worked on last week to start driving the motors a bit more and just like playing around with it in general. Yeah, that's it. Let's wrap it up. We were here before, want to wrap it up before, but yeah, thanks everyone for tuning in. We did not a lot of work, but a lot of progress, I think, or like other way around, like not a lot of progress, but a lot of work. Was fun, and enjoy your weekend. See you next week. Bye.